Hello and welcome to the third lecture in chapter 22, exercise portion. Now we are doing at present this sixth question. Explain the difference between scaling and normalization. Now this is just a theory question and provide a scenario where scaling would be preferred compared to normalization and vice versa. So we have done at least 3-4 hours of discussion about the topic of scaling and normalization. So here our chapter was like this. First was creating new features, then data scaling and normalization. And in data scaling and normalization, we did about min-max scaling, standard scaling. Then we did about normalization. The most important difference between scaling and normalization is both min-max and standard scaling calculate the values over a column. For example, the formula for min-max scaling is standard scaling is this: xi minus mu divided by sigma. That will give the scaled value of any xi observation, that is zi. Okay, the scaled value is zi. So then observation minus mean value divided by sigma, but it is the mean value of that column, vertical column, and standard deviation of that vertical column, right? Similarly, the formula for min-max scaling, that was this: xi minus minimum value of xi and maximum xi minus minimum xi. Again, this minimum xi is from x column, maximum is also from x column, like that. So any observation minus the minimum value of that column and divided by maximum value minus minimum value of that column, that would give the min-max scale value of that observation. But in normalization, we do the values which are used for normalization, they are calculated over rows and not over columns. So general formula for normalization is this, that it is xi divided by mode of x, where that mode of big X, that is called norm. And the norms are of three types. One is this L2 norm, that is at that time Euclidean value of the observation is taken. For example, if the row has 3, 4 as the two values, and I'm talking about row now. So this X is now not a column but a row. Okay, so column header will be here. Suppose age is equal to 3 and salary is equal to 4, where 3 means 30 multiplied by 10 and 4 means 4,000 multiplied by 1,000, right? So then in that case, this row will have how much norm value? Then L2 norm is under the root 3 square plus 4 square 5, and therefore normalized value of this row would be 3 divided by 5, 4 divided by 5. Instead of norm L2, you can take norm L1, where what is norm L1? That is the sum of the magnitude of each value in the row. So if this same row, 3 is the age and 4 is the salary, so the sum of their magnitude is 7, and divide by 7. So then 3 by 7, 4 by 7, this will be L1 normalized value. And the max normalized value, at that time you will divide by the maximum value in the row. So 3 and 4, these are the values in the row. Then 4 is the maximum value. So you will divide each observation by 4. So 3 by 4 and 4 by 4, that is 1. Okay. So in short, we had done a very, very detailed discussion, and therefore now I am not asking this question to ChatGPT and all that. In fact, I did ask, and whatever answer it gave, that I pasted in the this exercise answer, because that is just a theory question. But important thing about this is that part of the question, that is provide a scenario where scaling would be preferred to normalization and vice versa. That is, normalization would be preferred to scaling. So here, when to use scaling versus normalization? Scaling preferred, that is this all scenario, and normalization preferred, that is all this scenario. Scaling is preferred in linear regression. Now scaling means it may be min-max scaling or standard scaling. That again depends upon whether your which kind of output you want, whether you want a bound output or what. Okay, so that is fine, but both min-max or standard scaling is preferred for if linear regression you are doing, or principal component analysis. K means clustering you are doing, support vector machine. Now these three we have learned, but this we have not yet learned. And in this case, the mathematical assumptions are sensitive to the scale of the feature, and therefore first you do scaling and then you use this algorithm. So remember this. This is important in linear regression, principal component analysis, K means and SVM. Okay, you should first scale. Normalization is preferred while working with algorithm which rely on the magnitude of magnitude of vector. Vector, when I say, that means it is the horizontal, that is the row, right? So horizontal feature, such that when cosine similarity based model or gradient descent based model, that is say XGBoost or even neural networks, etc. So text classification, this we have not done. That will be a completely new topic like deep learning. Neural networks, this also we have not done. We will do it. KNN, that also we have not done, but we will do it. So all these algorithms are such that things should be normalized. Okay. Then some practical example of each is given, which is okay, fine, but this is the answer. So I am not going in much detail of that. I could have asked that question here, and I could have got the answer. Now this was the answer of the previous lecture's question, what is min-max scaling and all that. So I'm clearing it so that everything is clean back. Okay. Now this is one next question. Given a data set with features x1, x2, x3, x4 and a target variable y, apply chi-square test to select two best features and provides a Python code also and interpret the result also. Now this can be really helpful. Suppose you have been assigned a task from your college or from your employer that tomorrow come prepared with chi-square test, because I'm going to give you some task which will use it, and you want to understand what is chi-square test, and or you are an academician who is preparing a lecture on chi-square test, but you don't want to copy paste the data from some well-known textbook or some well-known website. You want to create your own synthetic data. So at that time, such a question you can ask to your large language model. We have done again very detailed discussion about this statistical test, not in this chapter. I think in this chapter it was not there, but one earlier chapter about hypothesis testing, right? So in this chapter, what parts are there? Data scaling, normalization, feature selection, and model evaluation. So there is no chi-square test here, but that was part of one earlier chapter, hypothesis testing and statistical testing. And if you remember, we took it as a very, very long chapter, 34 to 35 lectures, each of around 45 minutes were taken. So since we have done that discussion in detail, I am just creating the data and asking it to create data and give me Python code. And you can see in a fraction of a second, it starts giving you. On a free version of ChatGPT, it sometimes may take time, but still it is reasonably fast. So it is creating one synthetic data. This is data dictionary, dictionary, where these are the column headers, keys, x1, x2, x3, x4, and y. And these are the values. Okay, so these are different values. And now I am writing this df is equal to x and dfy. So that means if I put our well-known that diagram once again here, so that you come to know where exactly we are, this diagram I'm talking about. So let me copy paste this and come back to where it is required. So it is in the exercise section far below, right? So somewhere here, right? So here I can add one cell, make it mark down, and paste that image. So these many steps, x and y, that is splitting up to this level, right? Original data set, and then we are splitting into feature matrix and the target variable. So I can keep that much in one cell and rest of the things in other cell. Okay, and if you want to see what is the data frame, then you can put the data frame also, print df. Okay, so this is my data frame. These are my 4 features, and this is my response variable. Also, I have separated features and response variable. So green is features and yellow is response variable. Now I am using chi-square selector. So select k best. So I am using chi-square test for feature selection, right? So yes, that was introduced in this chapter. So it was used in this chapter only for feature selection, chi-square test. And we saw that there are many techniques. Select k best. Then there were some more techniques also, like forward feature selection and backward feature selection and recursive feature selection and all, right? So here we are using k-best, using chi-square test. And if you use this, then ultimately you get an output like this. So chi-square test for each feature, that is now here chi-square value is coming out to be 0. So still it has selected x3 and x4, right? So maybe it came out to be 0 because of some kind of rounding. No rounding has been done. Okay, so let us ask it to interpret that result, because interpretation it has already done. Okay, because we asked it in the question that why you have selected the 2 features and why you have not selected the other 2 features. Because if chi-square value of all is 0, then why certain features were selected and why certain features were not selected. So that means interpretation of result. So chi-squares and then selected features, a very small interpretation is given actually. Okay, so the output will display the chi-square score for each feature. Higher score indicates stronger relation with chi-square target variable. The code selects 2 features with the highest chi-square score. Now that I will have to ask more question, because here it is saying that I have selected 2 features whose chi-square score is highest, but I am getting all chi-square scores 0. So clearly some rounding off has been done somewhere. Okay, keep in mind that these features are considered the best based on chi-square test, and they are most significant. They have most significant association with target variable. We have done all this discussion a lot, so that is fine. But let me ask a counter question: that I got output like this, and you selected these features. My output was this. Okay, and I pasted my output. So all chi-square values are equal. Still, you selected x3 and x4. Why? So it has to explain. Just like if you are data scientist and you do something, then you have to explain to your boss. So while working with ChatGPT, you are the boss, and you have to ask. Okay. So it is trying to give some explanation. Now let me read first. If it is convincing, then only I will paste here. That output received where all chi-square code suggests that there is no statistical association between any of the features and the target variable. So this might occur due to several reasons: lack of variation, inappropriate data type, small data set. Okay, small hours is definitely small data set. So that might be one reason. Okay, recommendation: you do some data pre-processing like maybe scaling. No, scaling also is not required. What else data pre-processing can be done? Okay, verify integrity. Now that all these things will apply for a real data set. So here now they are saying that this my mutual information based classifier. So that I'm not interested. I am interested in why you selected these two. Okay, so that it did not give any answer. In fact, it just pointed to mutual information based classifier. So instead of this kind of thing, you have to say that maybe let me, but you actually gave answer selected features is equal to this, then on what basis they were selected. So you are actually behaving like a boss who is scrutinizing a junior data scientist. Selected if chi-square test was inconclusive. So here, of course, I should write that I don't want to use MI based mutual information based technique. Instead, I am sticking to that chi-square test and I am further drilling you, right? So yes, now it is giving you something that it says this reason looks convincing to me. Okay, all this I can put as an extra note. It says that selection by k-based can appear arbitrary, often defaulting to the first feature in the dataset due to the internal mechanics of its implementation. If the output explicitly indicates it is likely that x3 and x4 were selected, then default order following are maybe the reason. When all scores are equal, the select k-base might still return a subset of features based on their order in the dataset. Okay, now order wise also x3 and x4, maybe yes, it has selected the features with highest values that you can see. So that is completely false logic. So that means it has gone to that idea that bigger features, they have more impact on the this uh, target variable. Then implementation detail, depending on the version of scikit, that is okay. What you can do is, if you want, you can do following improvements: reevaluate the data, so that is fine. Binning the containers, now I don't have sufficient observation for binning, just hardly 5 rows are there. Or increase the sample size. Yes, that I can definitely do, because chi-square test also requires a certain minimum sample size. So I can say that instead of this kind of data, it should have been given me a data which was more suitable. So my data was as follows: give me more suitable data with number one. So give me more suitable data with 100 rows, and number two, maybe categorical and continuous, both variable. Also give complete Python code for conducting chi-square test on that new data. Of course, in the actual job, you will not be allowed to change the data which is given to you, but then this kind of data also will not be given to you. Data will be very complicated, mostly around 500 rows or 5,000 or even more than that. So this time we are creating the data, and we are also conducting chi-square test. So that means instead of all this, or okay, below this I will add one cell, and here I am creating the data and conducting the test. Now this time I am getting proper result. There were 4 features, but some of them were categorical, some were numerical, and rows are 100, and chi-square test selected that these are 2 features which are most significant. So ideally, while making the question, I should have been more careful, right? So instead of this data, I can give that data, and thereafter rest of the things you can do by asking to the ChatGPT. So this much is your data. So I change my question so that the question remains meaningful to you and it gives some proper answer. So this is the data frame. And now question remains same, that this is the data frame with 4 features, x1, x2, x3, x4, and target variable y. Apply chi-square test to select 2 best feature, give Python code, and discuss the results, interpret the results, right? Okay. Now I will delete this old code, that is this cell, this cell, this cell also, and I am keeping this result that is for that. Its interpretation is okay. I am not keeping that interpretation, but you can do, or let me put. Otherwise, interpretation is clear that these two are most significant features and highest correlation, highest role in deciding the target variable. And even in them, x1 has very small value of chi-square 0.177, while x2 has 2.44. So even compared to these, this is nearly 15 times larger. So you can say that x2 seems to be the most important features as far as. So I am asking it to interpret my result. What I just now said, that x1 and x2 are interpretation of my result. This is my result. So give interpretation of my result. Okay. And as I give interpretation, ask for interpretation, and as it gives interpretation, it gives a pretty lengthy interpretation and even suggests what should be next steps. So you can see that this is the way nowadays data science is done. Okay. It is a lot of labor has been saved. In fact, we who worked in absence of these large language models for years are frankly a little bit jealous of your generation, those who are newly entering, because a lot of labor has been saved. At the same time, I once again warn you that never take anything which is given by an AI tool at its face value. Read each and every line. Here I am just keeping for you, but you will read each and every line and check for validation. We had to work hard, but because this ChatGPT etc. came in 2024, 23, and I passed my PG diploma in data science in 2018 and masters in 2020. So in one way, it was good that at least we can say that we passed without the help of any AI tools, because they did not exist itself at that time. But in other way, a lot of labor is manual labor we had to do. That gave us certain edge also, certain depth also. And if you want to take the best of both worlds, then you don't just copy paste here and go to the next question, then again copy paste here and go to the next question. No, think each and every line, what answer is given, check it, if required, go back to the lectures, theory lectures where we have done that. So here, for example, it says that chi-square score of 2.5 is higher than x1, suggesting stronger association. So that is what I said, that even before asking to any ChatGPT, that x2 is very, very large, 15 times larger chi-square than x1, right? So x2 might be more informative in predicting y, but more statistical testing will be required to confirm. So it gives next few tests that find p-value also, consider sample size also, and do some feature engineering if you require, and modeling approach also, try different modeling approach. Okay. Now in next lecture, we will start with this recursive feature elimination for feature selection and role of lasso for feature selection. So we have done that also in much detail in our feature selection part. Okay. So if you want to see that, then it was filter method, mutual information, then embedded methods were forward feature, wrapper method, backward feature, recursive feature elimination. All those things we have done, right? Then lasso in the embedded method. So one was lasso regularization. So all those things we have already done in much detail. So hopefully you are remembering that the exercise which we have given here, they are never on a new concept or something. They are on the concept which was already discussed during the course of the chapter. Okay. So if you still bring that kind of doubts that I cannot understand this exercise question at all, then I think that that would be a little bit unfair on me, because I have taken care of designing the chapter as well as exercise so that everything that is asked in the exercise is already covered in the chapter. Here also I will delete this portion and delete the previous also, so that I start with a clean slate when I start my next time. Yes. Okay. So see you in the next lecture.